machine learning, quantum machine learning, which are tools that humans use to be able to solve really tough problems. And as a result, the rate of growth in these spaces has been exponential. But something really interesting is even though machine intelligence is going up like crazy, human intelligence has remained stagnant over time. And a lot of smart people are worried about that because they think that the only way humans are going to be able to solve really tough problems in our future is if we increase human intelligence as well. Which is why I'm super excited to share with you all the awesome field of brain-machine interfaces. So it pretty much allows your brain to communicate with machines, or communicate with computers, or potentially even communicate brain-to-brain communication, or even communicate with things that are completely inconceivable to us now, like the internet. So brain-machine interfaces are super interesting, and you've probably all are at least aware of one application, which is prosthetics. It takes inputs from your brain to try and decide what you mean by arm up, and then activate a piece of hardware to move an arm up. But there's actually a ton more interesting things being done in the field. DARPA, which is the US military's innovation funding agency, has been giving out hundreds of millions to get people to solve really tough problems in relation to brain-machine interfaces. In 2015, there was a TED Talk in which you could control someone else's arm with your brain. There's tons, like Facebook's working on applications to let you type with your brain. There's a lot of cool work being done in this space. So I'll quickly explain how it works. First, it collects inputs from your brain using a wide variety of different technologies. They all have their different pros and cons, but the one that's probably most widely used is EEGs. So you can get different information from your brain, either semi-invasive, non-invasive, or invasive. And typically people with prosthetic arms opt to go for the more invasive approaches because it allows for more clear signals and better calibration. But when I was playing around with the stuff, and maybe you guys tried out Muse today, that would be an example of non-invasive sampling. And for an EEG, for example, you get different inputs that look like this. They're just different brainwaves. And each brainwave corresponds with things that you're doing in your environment. So if you're focusing, your alpha waves might go between 7 and 12 hertz. Whereas if you're sleeping, you might get like beta waves, or theta waves, or delta waves, or gamma waves. And they all happen in different frequencies. So once you have this different input, you run it through software. You can decide whether or not you wish to use machine learning or neural nets to be able to figure out what this actually means. And when it goes through the software, you then get your output. The software is not the most beautiful thing that exists, but it does what it needs to do. And you activate your output, and you can pretty much control whatever you would like. So there are currently 3 really sick companies in the space: Neuralink, Facebook, and Kernel. And they're all in a race to develop the first neural interface to try and interact with people. And a lot of these CEOs think that easily in 40 years or 50 years, we'll all have brain chips allowing us to do things that we can't even think of right now. So I became super interested in the field because I realized that it would make a huge impact on the world. The technology relatively makes sense, and there's a lot of growth that can still be done. So I built my first project. Let's see if we can get this video to play. Maybe not. But it was me turning music on and off with my brain. Oh, click it.
Start focusing in 3, 2, 1.
And I used drum noises because I didn't want to copyright, but you can use any MP3 file.
And now I've stopped focusing, and as you can see, now that I'm not focused, the drum sounds have stopped. And that's because I'm not focusing, and I can just do it one more time. I'll focus again,
so
3, 2, 1, and then when I want to stop focusing.
A whole bunch of times in my video. And I thought that was super cool. It was the first thing I had done in the brain-computer interface space, and it allowed me to see, wow, I could have actually done something. So
okay, so now here's a demo of me controlling this car with my brain. I'll just turn it on.
Okay, we can watch this video as well. This happened 3
Start
months later.
Stream.
Or, no, I don't think it was 3 months. 2
And
months.
I will turn on the car.
And when I focused, the car moved forward. When I stopped focusing, the car would stop. And when you jaw clench, your neural signals, so your EEGs, go completely out of whack.
And I'll stop the car in 1, 2, 3, stop.
Usually it's about like 20 hertz, but when you jaw clench, it goes to like 300 hertz.
And now I make the car turn.
So I use that to turn the car.
And now the car should stop. And now the car will run forward. And I'll make the car stop in 3, 2, 1.
And I was super pumped because I thought that was super cool. And essentially, I used like different gold cup electrodes taped to my face and taped to my ears. The reason you tape them onto your ears is because everyone has different neural signals, so you want to calibrate it with like a baseline. And then the one on my forehead picked up the things that I was doing to control the car: focus, non-focus, and then jaw clenching. So I thought that was really cool. And next slide, that would be awesome. Yeah, so I realized, wow, if I could have built this application that lets me do a whole bunch of things with my brain signals, I think that, yeah, in 40 years, it might make sense that we'll all have a lot of brain-computer interface chips and be able to do a lot of really interesting things. But that led me to think a little bit more, and I realized if we have brain chips in all of our brains, it'll be generating a ton of data. And people are extremely worried about that. People are worried about like Facebook knowing what buttons you press and what public photos you look at. But this type of technology would allow companies and organizations to know how you're thinking, how your brain works, like speeds that your synapses are firing, literally everything that makes up who you are biologically. So then I got super interested in the blockchain space. Well, actually, I was interested in the blockchain space before, but I built something, and I won a hackathon, and it pretty much used IPFS, which is a distributed file sharing system, to allow users to upload data, have it be completely secure, but if they wish to share the data, they could still share it anonymously and get paid for it without the person paying them knowing who they are. So I framed it with the application of genomic data because it's actually a huge problem in genetic data as well. Like 23andMe knows everything about you. And this type of application would allow you to still provide information to researchers, to allow their AI and ML mechanisms work with good data from across the world, but you could still get paid for your contributions while being anonymous. And then after I built this stuff, a whole bunch of companies decided to help me out, and I was really grateful for that. So I guess in the future, something that I'm looking into is intersections with VR games and worlds, which you'll hear Sabarish talk about after, and they're super cool. I think they make a lot of sense, and one of our futures might look like us spending a lot of time in VR. And I thought to myself, well, if we're spending time in VR, it's not going to be with an Xbox controller. I can barely play Fortnite because it's too many buttons. So I think we're going to have brain-computer interfaces. So I'm making my first first-person shooter that shoots when you focus and do a whole bunch of other inputs. But I think the field is super interesting, and brain-computer interfaces will definitely be our future. I think the only way we'll get the best future for humanity is if we have a lot of people working on really tough problems. And I think the only way smart people will be able to solve these tough problems, especially if they're competing with AI or ML, is if we're able to have this other-world intelligence and increase human intelligence as well. So I think brain-computer interfaces are super interesting. You should all look into them, and it's an absolutely crazy world. Thank you so much.